Assalamu alaikum everyone. I hope you are fine and doing well. Today my lecture is about cryptographic properties of strong Boolean functions. Uh, Fundamentally, this topic is further I have classified this topic into three uh, very small lectures. So, in order to understand this whole topic, cryptographic properties of strong Boolean functions, you have to have follow these three, uh, my oncoming three lectures. So, first of all, I have divided this topic into three subtopics. First one is Boolean functions, then some cryptographic properties of Boolean function, and finally, who will discuss nonlinear confusion component and how one can classify different type of nonlinear Boolean functions. So nonlinear Boolean functions are considered for a long time to construct uh, symmetric key crypto system. I mean to say it's one of the component of modern block cipher. We call it confusion component, and or sometimes we call it as a substitution box. Basically, it is used to resist some known attacks, and many properties of Boolean functions are utilized in order to verify, in order to test the what you call the robustness of nonlinear confusion component. So in this lecture, we will analyze what type of Boolean functions are there and how some Boolean function, we call it linear, and how we can classify the nonlinear Boolean functions, which is majorly interest we call it, we are majorly concerned about nonlinear Boolean functions. So let us start with some basic definitions. So the first definition is what is Boolean function. So if you can see this one, so this is the Boolean functions that map n variable to some single variable. So I can say this is a single valued Boolean function that take an input and map on single output. So the another question is how we can construct how many Boolean functions on binary input. So there are 2 to the power 2n Boolean functions, and out of which 2n are linear Boolean functions, and rest are basically 2 to the power n minus 2 power n are nonlinear Boolean functions. For example, if I take n equal to 2, then f is ranges from z2 to z2. Or I can write it, since this is z2 to the power 2, so I can write it like down like cross product. Z2 cross Z2 tends to map on Z2. Or I can sometime, in some books, we can write it like f from 01 cross 01 map to 01. So I write it like this. So in this set, I have what you call 4 possible values, and in Z2 I have only either 0 or 1. So if you can see, look over here, this is the cross product of these two sets, and I will get 4 elements, and these 4 elements are basically map on either 0 or either 1. So let us see some characteristics, what you call how we can furtherly represent these Boolean functions. If you can look over here, this is the logic circuit diagram of Boolean functions. That is, n-dimensional Boolean function is map on m-dimensional Boolean functions. So this is one of the logical circuit that take an input and map on M output. This is the logic circuit diagram of Boolean function. And there are fundamentally three basic binary operation for logical values. They are AND, that is the expression for this x and y, or in some time we can write it x dot y, or operation which is has two input, that x plus y not, that is complement of any argument. So in a truth table we can write it down x y, it has four possible values. If you can see this one, so the and is 0 times 0 is 0, 0 times 1 0, and 1 times 1 is 1. So if you can look over here, this is the addition, or I can say or operation, and sometime we can write it down x and y, or sometime we can write x or y. So or in some books we can write it like x bar. Okay, these are some of the basic operation. Rest of the Boolean functions are the possible combination of these basic Boolean function. I mean to say and, or, and not. These are basically three basic Boolean functions, and rest of the Boolean functions are based on these. If you look at over here, so how many Boolean function, or when input is 2, I mean to say you have only two inputs, so there are 2 to the power 2 to the power 2, there are 16 different Boolean function when n is 2. So these are just, if you can look over here, so how we can construct, so how many single Boolean function, I mean to say if f is from z2 to z2. So how many single valued Boolean function I can say? I can construct 16 possible Boolean function, or when input is 2. So when input is 2, all possibilities are 4. So 0 0 1 1. So 0 1 0 1. These are fundamentally input, that is from this set is fundamentally belonging from, this input is belonging from z2 cross z2. If you can look over here, these are 0 0 0 1, then 1 0, and 1 1. So these are all possible Boolean function. If I take this function take two input, and every input map on 0, 0 0 is map on 0, 0 1 is map on 0, 1 0 is map on 0, so 1 1 is again map on 0. So if you can look over here, f2, this is 0 0, 0 1 is again 0, so 1 0 is again 0, and 1 1 is 1. So if you can look over here, the f2 is nothing, it is just an logical gate. So these are what you call the AND. So rest are all, you can say, other Boolean functions which are possible on two input Boolean functions. So we can, how many Boolean function we can construct? We can construct all possible 16 Boolean functions. Uh, if you can see these in terms of uh, logical operators. So if I can say if n is 1, so how many possibilities when n is 1? So I have only two possibilities, 2 power 1, which is 2. So I have two possibilities, 0 or 1. So in that case, my input will be 0 and 1. So how many Boolean function I can construct? 4. The first Boolean function is it map 0 on 0, and 1 is again map on what you call 0. Then this f2, what does f2 means? It maps 0 on 0, and 1 is map on 1. So if I can say f1, when you put 0, it will give you 0. If you put f1, then it will again give you 0. If I talk about f2, if you put 0 input, so you will get output as a 0. If I put 1, you will get 1. So if you can talk about 3, if you put 0, then you will get output as a 1. If you put 3 in F3 as a 1, you will get 0. Another function F4, if you put 0, it will give you 1. If you put 1 as an input, it will give you again 1. So these are all possible Boolean functions when number of inputs are a single input. When number of input is each time input is just a single element. In last case, if you can see over here in last, so in that case, if I can, so in that case, every function, if I can say f1, it take two element and map on one element. So in that case, if you can see this one, it map on either 0 or either 1. So in that case, if I can see z22 is just a single valued Boolean functions. So here all these 16 Boolean functions are single valued Boolean functions. Or if I can say this one f2, what does it means? F22 is again single valued Boolean functions. So all these are and, or, nor, not, all these basic Boolean functions that is defined on any logical circuit is defined over here. So let me elaborate this. These are all what you call, these are functions. These are all possible Boolean function on two variables, that is x and y, 0, 0, 0, 1, 1, 0, 1, 1. So this is a constant. This is, I call it as a zero, constant zero function. It is possible I call it as a f1 in my previous slide. And n x time y, this is my f2. If you can see in previous slide, then x and not y, x and not y, I call it as a f3, and so on. How many Boolean function we can construct? We can construct all possible 16 Boolean function. If you look over here, basics are negation and or Boolean functions. Rest are, you can see over here, the linear are you can see the combination of uh, and, or, and complement. And you can see this is dot and this is plus and this is I can bar it. So if you can look over here, so these are and negation. This is simple x, this is negation of x and y, and these are the possible combination of and, or, and complement. So these are all possible. What you call it, this is f1, this is f2, this is f3, and so on. If you can see this, this is f16. So these are just input. This is input, input, two input, and this is single output. 0, 0 is map on 0, 0, 1 is map on 0, then 1, 0 is map on 0, and 1, 1 is map on 0 under f1. So these are the all possible Boolean function on two variable. So Boolean space. So if you have just only one element, it is either 0 or 1. We can call it as 0 dimension. And this is one dimensional. It has two element. I can call it Z2. It is 0 and 1. So it is two dimensional. So Z2, 2. I call it Z2 into Z2, and this is 0, 0, 0, 1, 1, 0, and 1, 1. So if I can remain this, so this will be my 0, and this is 1, and this is 0, 0, this is 0, 1, this is You can call it as a 0 1, and this is my 1 1. So if I can see this three dimension, this is again z2 3. So it has z2 2, and this is z2. So it has two elements, it has four elements, and it has uh, 3 bits, 8 element. If I can call it 0 0 0 0 0 1 0 1 0, then 1 0 0, then 0 1 1, then 1 1 0, then 1, then I can call it as a 101, then triple one. So these are all possible, eight possible combination, and this is three-dimensional binary field, vector field. So this is again four-dimensional. You can call it as a Z24. So it has the cardinality of this is how many element it has. It has what you call the, I can call it as a cardinality of this is 16, and the cardinality of this is 8, and the 8 I must write it loud, and this is again 4, and the cardinality of this is 2. So it has what you call a first element 0 0 0, then 0 0 0 1 0, so 0 0 1 0, and so on. If you can see this one, the last element will be 1 1 1 1. So in that case we can write it like this, uh, cuboid. So we can write it like this one. So these are just interlinked. So I can say we are just can represent 16 element in this way. So these are what you call, if I can 0 0 0, and this is my x-axis, and this is my y-axis, and these are z-axis. So this is a unit cube. So in that case this will be 1 0 0, this will be 0 1 0, this will be in space, so it will be 1 1 1. So this is in x, this is again on z axis, so it will be 0 0 1. So this point is in xz plane, so it will be like 1 0 1. So this is in xy plane, this is 1 1 0, and this is again yz plane. So the coordinate of this point will be 0 1 1. So in that case we can denote the different Boolean spaces, and their geometrical representation can be elaborated with this slide. So another class, how to classify the group of linear and nonlinear functions. There are two types of Boolean functions generally, which are quite helpful in cryptography. One is linear Boolean functions, and second one is nonlinear Boolean function. If I talk like in cryptographically, so the linear Boolean functions are, we call it as a P boxes, permutation boxes, and nonlinear function are substitution or S boxes. So there it provides diffusion, and this provide confusion. And these two terms will be elaborated in my next lectures. So the current this currently I am focusing how to classify either some Boolean functions is linear or non-linear. I can call it as any Boolean function with n variable is set to be a linear if it satisfies the properties of linearity, and this is the property of linearity. Here x is n-dimensional vector and y is also a n-dimensional vector. So how many linear function we can construct on binary vector space? So these are 2 to the power n. So non-linear Boolean functions are we can construct on n input Boolean functions. There are 2 to the power n minus 2 power n nonlinear Boolean functions. So affine, how many, the cardinality of affines are 2 to the power n plus 1. So if I can say n is 2, so the linear, so it must be like 2. So how many Boolean functions? We have 4 possible Boolean functions. So it should not be 3, it must be 2. So in that case, dear students, the nonlinear Boolean functions are 12 when number of input are 2. So I must say number of input when I am saying, it means I am talking about Z22. So it is 0, 0, 0, 1, 1, 0, and 1, 1. So you have when n is 2, number of input are 2, so all the possibilities are 4. So in that case, we can construct 4 linear Boolean function and 12 nonlinear Boolean functions. And affines are part of these nonlinear Boolean functions. Let us take one Boolean function. It is single valued Boolean function that take to input and map on single output. This is like as is said, I call it 0, 0, 0, 1, 1, 0, 1, 1. This I call it as a set of two input and consider this Boolean function. I just take x from what you call x and y belonging from S, any element of S, say I take 0, 0 and y as a 0, 1 from set S. Then I add them just to get 0, 1. Then I apply f on this input output of this one. Like if I add this, I will get 0, 1. If you can add this x plus y, what you will get? 0, 0 plus 0, 1. What you will get? You will get 0 and 1. Here, if you can see this one, so I apply f on this 0 and 1. So apply f 0 and 1, this one. What I will get? I will get 0. When f is applied on 0 and 1 input, 0 and 1, the output will be 0. So individually I apply f on x. X is 0, 0. F is 0, 0. So individually f is 0, 0. F of y. Y is what? 0, 1. So then I again get 0. So f of x plus f of y is 0. So f of x, when f apply on the addition of y, and when you individually add f of x and f of y, the result are same. So in that case, the f which is given over here is linear Boolean functions. So so this is linear Boolean functions. So let me elaborate uh, that number of linear Boolean function when z2 to z2. So here n is, if you can see over here, the n is 2. So the linear Boolean functions are 4. That is on 2 input, that is all possibilities are 4. So in that case, I just take f1, f6, f10 and f7. These are all linear Boolean functions. Why? Because these f1 satisfy this property x plus y, f1 of x plus f1 of y. Similarly, f6, f10 and f7 also satisfy this linearity property. So in that case, we can say all these 4 Boolean functions, 4 single valued Boolean function, that is from fi from z2 to z2, these are linear Boolean functions. So what is affine functions? Linear, if we add this factor in linear Boolean functions, these are linear Boolean functions. I can write it in a short form, take its transpose of this one, that is this one. So I can write it instead of column wise, I just write it as a row wise. So I just add it. So I will get F16. Then I add this one with vector of 1 1 1 1. So I get this one. This is f8 f9 and similarly f11. So all these are non-linear Boolean functions, and since these are affine, so these are non-linear Boolean functions. So dear student, today we this lecture is all about how to classify linear and nonlinear Boolean functions, and then we draw a number of Boolean function or an input, and then we note it down that what is Boolean functions. I just talk about single valued Boolean function that take many input and map on single output. That is for in each time, if you can see this one, two input is map on one input. Again, two input is map on one input. Again, two input is map on one output. So again, this two input is map on one output. So in that case, I call it single valued Boolean function. So till then, Allah Hafiz, may Allah bless you all. So we will in next lecture we will talk about some cryptographic properties. Till then, Allah Hafiz, may Allah bless you all.